Right, so for this chapter, we're going to be looking at correlation and a linear regression line. So first things first, we need to draw a scatter diagram. And a scatter diagram is drawn when we have a data which is bivariate. Now, bivariate just means it's a data which is two variables, i.e. x and y. Okay, and so these variables are given a specific name. So we have, on the x-axis, we have the independent variable, sometimes known as the explanatory variable. So this is the one we change up, or it's changed up on its own. And this will affect the dependent variable on the y-axis, or sometimes known as the response variable. And so what we can do, because it has two variables and two values, then we can plot a graph, a scatter diagram like here, like x with its x points. And with this, we can draw like a straight line equation or a straight line graph like so, and then determine whether the two data are correlated or not correlated. All right, so correlation is determined by something called this R value here, and it's got a value between -1 and 1. So if it's a positive value closer to 1, then we say it's got a positive correlation, meaning that if the independent variable increases, then the dependent variable would also increase. If it's a -1, which we call it a negative correlation, meaning that if the independent variable increases, the dependent variable actually decreases. And so it's just between the -1 and 1, this R value. And the closer it is to 1, the more strong this correlation is. So as you can see here, if it's roughly bigger than 0.7, then we call it a strong positive correlation. And you can see that the X marks are actually mainly on the line, right? They're very close to the line. If it's less than -0.7, then we call it a strong negative. And once again, the X points are very closely linked or close to the line. Now, if it's between -0.3 and -0.7, we actually call it a weak positive, okay? Because it's still increasing upwards. As x increases, y would increase. But as you can see from the x positions here, they're actually quite far away from the line. And so even though it is a positive correlation, it's not very strong, so we call it a weak positive. Same thing goes for the weak negative. If it's between -0.3 and -0.7, then we call it a weak negative. Now, if it's between like -0.2 and 0.2, then we could just say it's no correlation. There's no relationship between the x value and the y value, or the independent variable and the dependent variable. Right, now a couple of just key one-mark questions and tips for the exam. So there's something called a causal relationship, okay? So this is a causal relationship is when if a change in one variable causes a direct change in the other variable. What this means is that even if it's correlated, it does not mean it's a causal relationship. It just means that they're just related in some way. It doesn't mean that if I increase x, it automatically increases y. So you just have to be aware that not all correlation has a causal relationship. And we'll figure this out by using just common sense and the context of the question. I'll go over this in a bit later on. Right, common questions. They might say interpret the correlation. So what does a correlation mean? So what you have to say is, as the independent variable, so you'll be given the names of the independent variable. It could be like height and weight or something like that. So as the independent variable increases or decreases, then the dependent variable would increase or decrease, depending upon what type of correlation it is. So if it's a positive correlation, then you say as the independent variable increases, the dependent variable would also increase. Or if it's a negative correlation, then you say as the independent variable increases, the dependent variable would decrease. Okay, so it's all matter of the context of the question. Right, give a reason why a positive correlation may not be invalid. And in this case, you would have to say because it may not be a causal relationship. An example of this is if I were to draw a scatter diagram, and let's just say I have on the y-axis like house price, and on the x-axis I have bedroom size. Okay, and then I can say that it's got a positive relationship like this. And so you could say, oh, well, look, as the bedroom size increases, the house price would also increase. However, this is not necessarily the case, right? Because it could be other factors which increase the price of the house. More importantly, it could be like the number of bedrooms. That could be a more direct comparison of the house price, right? Rather than this bedroom size. So we can't necessarily say, just because the bedroom size is bigger, the house price is going to be bigger or larger. But that's not the case in all cases, right? So this is an example of what a causal relationship is and is not.